In this problem, we're going to find the equation of a normal line. The problem reads, what is the equation of a line normal to, and we better define normal, to y equals the square root of 2x squared plus 3x minus 2 at the point 3, 5. And if we have just kind of a generic curve and we want to find the tangent line to a particular point on the curve, it's a line that just touches at one point there. And so what's the normal line? The normal line at that point travels through that point and is perpendicular to the tangent line. So there's a right angle formed there. And so the line perpendicular to the tangent line is the normal line. Okay, I've written down some steps that we need to take to solve this problem. The first step is to take the derivative to find the slope of the tangent line at the point. Then we'll find the slope of the normal, which is the perpendicular line, the normal line, perpendicular line, and we'll use the point slope form for the equation. And if you hope you remember that it's y minus y1 equals mx minus x1. And then we'll put it in standard form, ax plus by equals c, because on the AP exam it will probably ask for you to put this equation in standard form. Okay, so let's get started with the derivative. Let's first write our function down again. It was y equals the square root of 2x squared plus 3x minus 2. And it's always helpful to write our equation with instead of with a radical, to write it in exponential notation, and so we'll do that. So instead of the square root of 2x squared plus 3x minus 2, we'll write it to the 1/2 power. And just to remind ourselves, it's at the point 3, 5. Let's take the derivative. It looks like we need to use the chain rule, so the derivative of the outside function is 1/2, and then we'll just write the inside function in here, 1/2, and then we're going to decrement the exponent by 1, so we'll now have 1/2 our function, inside function, to the negative 1/2 power, and then times the derivative of our inside function, which is 4x plus 3, and then minus 0 because the derivative of 2 is 0. Okay, now we don't want to simplify this. It looks like it would be a mess to simplify. So don't simplify at first. Don't simplify first. Just plug in. It's much simpler to do this simplification if we just plug in the value for x, which is 3, and just working with numbers, it'll be much easier to simplify then. So that's what we'll do. We'll rewrite our derivative, and every time we see an x, we'll replace that x with 3, so 1/2, 2, and then there's an x, so let's replace that with 3. We're going to square that, plus 3 times our variable for x is 3, our value for x is 3, minus 2, and we'll raise that to the negative 1/2 power, and then that's times 4 times 3, we're plugging in again for x, plus 3. Now it's time to do some simplification with just these numbers in here. So let's see, we'll have 1/2, and let's see, 3 squared is 9, times 2 is 18, plus, and then 3 times 3 is 9, minus 2, that's raised to the negative 1/2 power. And we can simplify this a little bit over here. 4 times 3 is 12, plus 3. And let's keep going. That's now equal to, let's see, what is 18 plus 9 minus 2? 27 minus 2, I think it's 25 to the negative 1/2 power, and of course 12 plus 3 is 15. And so now let's see. Let's put everything that would be in the numerator here. That would just be 1 and 15, or 15 times 1. And in the denominator we'll have the 2 and 20. The square root of 25 goes in the denominator. We'll go back and write that in radical form. 25 to the negative 1/2 is the same as 1 over the square root of 25. And that is, in the numerator we have 15, and in the denominator the square root of 25 is 5 times 2 is 10. This reduces down to 3/2. All this to find the slope of the tangent line at 3, 5, but we don't want that slope. We want the slope of the line perpendicular to that, and that would be the reciprocal and the negative reciprocal. Remember, to find the slope of something perpendicular, you take the negative reciprocal, or rather, the opposite of the reciprocal. All right, now we have the slope. We have a point. We're ready to write our equation in point slope form, and that would be y minus y1 equals m times x minus x1, and our point was at 3, 5. So 5 is the y value, and let me just write down again what our point is that we're talking about, 3, 5. M, we know what m is, that's negative 2/3, and and it's x minus then the x value, which is 3. On the AP exam, this equation is most likely put into standard form. So let's multiply everything by the denominator that we have here, which is 3, and that will give us 3y minus 15 on the left side of the equation. On the right side, it'll clear out that denominator, and we'll just have negative 2 times x minus 3 there. Now let's distribute on the right hand side. We'll get negative 2x plus 6. Moving the x term over to the left hand side, we'll have 2x plus 3y, and moving that negative 15 constant term over to the right hand side, 15 plus 6 is 21. And that's the equation of the line normal to the function that was given through the point 3, 5. See ya.